Now see, principle of conservation of linear momentum. See, according to this principle, in an isolated system, the vector sum of linear momenta of all the bodies of the system is conserved and is not affected due to their mutual action and reaction. So, this is the principle of conservation of linear momentum. First, we have taken an isolated system. There is no external force. There are only forces acting due to mutual action and reaction. So, you can say due to mutual interaction. If these conditions are there, then the total initial momentum is equal to total final momentum. So, let us see its proof. Suppose there are two bodies A and B. Both are moving with the velocities initial momentum Pa and this has got the initial momentum Pb. This is M2. There is no external force. Both the bodies are moving here and suppose they collide for the small time interval, that is delta t, they are colliding. When they collide, their momentum changes to Pa dash and Pb dash. In that case, Pa dash and Pb dash, their final momentum changes to Pa dash and Pb dash. Now, we can write the force acting on the body A. We can write Fab is equal to force on A due to B is equal to rate of change of momentum of the body A. So, its momentum has changed P dash A minus P Pa divided by delta t, that is change in time. Similarly, we can write Fba is equal to Pb dash minus Pb divided by time interval. So, this is the force acting on B due to A, this is the force acting on A due to B. Now, according to Newton's third law of motion, we can write Fab is equal to minus Fba. So, we can write Pa dash minus Pa upon delta t is equal to minus Pb dash minus Pb divided by delta t. This cancel. So, we can write here Pa dash plus Pb dash is equal to, that we will take that side. So, Pb plus Pa dash. This is total final momentum. Total final linear momentum is equal to total initial linear momentum. So, this is the principle of conservation of linear momentum.